Hey, welcome to Passages in Applied Mechanics by Dr. Lorenz Garcia. Today, Dynamics and Simple Machines. In this lecture we are going to examine some example of simple machines, but, what do we mean by simple machines? From thousands of years, humans have used machines to help them perform difficult tasks. By taking a force and making it bigger, a big force working for a short time can do the same amount of work as a small force working for longer. Simple machines can help us to lift or move objects that would be too heavy to move by hand, from early beginnings of mechanical engineering science. 5 fundamental devices have been regarded as the Mighty Five, and they are called simple machines: the lever, the inclined plane, the wheel and axle, the pulley, and finally the screw. These are the most basic but, attention, the most important elements of mechanisms used in engineering. Why, think in a bicycle for example. A bicycle is a compound machine made up of several simple machines: levers, brakes, gear shifters and handlebars, pulleys, chain on the gears, parts of the shifting and braking mechanisms and the drive train, inclined plane, wedges and screws, teeth on the chain rings, screws that hold the bike together. The tire repair kit uses wedge and lever, and finally, the wheel and axle, the wheels, pedals and crankset. A compound machine is a machine consisting of 2 or more simple machines. Some examples of compound machines are clippers, a manual pencil sharpener, a crane, a bulldozer, etc. Therefore, because of it, it has been said that each one of the Mighty Five can be combined to achieve an almost infinite variety mechanisms to address endless applications and design all kinds of modern machinery. In this lecture, our aim is examine the operating principles behind the 5 simple machines with respect to their basic attributes, such as velocity ratio, mechanical advantage, and efficiency. Velocity ratios of simple machines. Problems dealing with machines usually involve the calculation of their velocity ratio. The velocity ratio, VR, of a particular machine is independent of load and friction and depends only on the dimensions and arrangement of the moving components. Let us calculate it for various simple machines. The lever. The lever is the simplest machine. It consists of a rigid bar pivoted at a point called the fulcrum, with a load applied at one point on the bar, and an effort at another point sufficient to move or balance the load. A lever which is bent is called a bell crank lever. It is used to provide a change in the direction of the applied forces. The lever has been used since early times for moving or lifting heavy stones and other objects, and it is the fundamental principles of multiple systems and devices. For instance, a pair of scissors, claw hammer, to pull nails from wood. A wheelbarrow is designed also based on the principles of the lever, a nutcracker, a bottle opener, or the brake pedal of a car. Close to my area of work and expertise, biomechanics and biomechanical engineering. The lever is the principle which governs certain elements of our human body, for instance, the mandible of a human skull, and based on its principles is how many elements in our body operates. Are you able to identify the lever mechanism in these elements of our body? The malleus, incus and stapes are small bones in the middle ear, connected as compound levers, that transfer sound waves from the eardrum to the oval window of the cochlea. Many modern machineries also consist of a combination of straight and bent lever arrangements connected together. The velocity ratio of a single lever arrangement is equal to the ratio of the perpendicular distances from the fulcrum to the line of action of the effort, dE, and the load, dL. Therefore, the inclined plane, also known as a ramp, as a simple machine, is a surface inclined at an angle to the horizontal used to lift a load by an effort acting parallel to the plane. Examples vary from a ramp used to load goods into a truck, to a person walking up a pedestrian ramp, to an automobile or railroad train climbing a grade. It is said to have been used in Egypt for moving heavy stones in the constructions of pyramids. Nowadays, inclined planes are widely used in the form of loading ramps to load and unload goods on trucks, ships and planes. Roads for vehicles and railroads have inclined planes in the form of slopes, ramps, and causeways to allow vehicles to surmount vertical obstacles such as hills without losing traction on the road surface. Similarly, pedestrian paths and sidewalks have gentle ramps to limit their slope, to ensure that pedestrians can keep traction. Inclined planes are also used as entertainment for people to slide down in a controlled way, in playground slides, water slides, ski slopes, and skateboard parks. Modern machinery often employs the principle of the inclined plane for various sliding surfaces, cams, and metal cutting tools. The velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load in the same time. When the effort moves along the plane distance, d, e, the load moves through a vertical distance, d, l, in example, in the direction in which the weight of the load acts, hence, the equation applies. Wheel and axle, in this case, the effort is applied at the circumference of the wheel while the load is raised by a rope wound around the axle whose diameter is smaller than that of the wheel. The wheel and axle can be viewed as a version of the lever, with a drive force applied tangentially to the perimeter of the wheel, and a load force applied to the axle supported in a bearing, which serves as a fulcrum. The velocity ratio is equal to the ratio of the radius of the wheel to the radius of the axle. It is usually more convenient to express this ratio as the ratio of the two diameters, d, w, and d, a. I let you to think in modern applications where you find the wheel and axle mechanism. Look around you, pulley and pulley block. The pulley is one of the most useful of the basic simple machines. It consists essentially of a wheel with a grooved rim carrying a rope or chain and supported in either a fixed or a movable bearing block. A system of fixed and movable pulleys with a continuous rope can provide a useful mechanical advantage, from the geometry of the block and tackle arrangement such as the one shown in the figure. It can be shown that with pulleys blocks using one continuous rope, the velocity ratio is equal to the number of falls of rope supporting the load. Pulleys are also assembled as part of belt and chain drives in order to transmit power from one rotating shaft to another, as we are going to discuss later on. It is said there is a famous scene where Archimedes proved the effectiveness of compound pulleys and the block and tackle system by using one to pull a fully laden ship towards him as if it was gliding through water. Screw jack. A simple screw jack is a portable lifting machine used for raising heavy loads through a short distance. It consists of a screw raised by a nut rotated by the effort applied at the end of a long arm. In some designs, the screw rotates within the nut, which is part of the main body of the jack. In either case, for each revolution of the arm, the distance moved by the effort load is raised by an amount equal to the lead of the screw. Thus then, when the distance moved by the effort is dE equal to 2 pi r, where r is the length of the arm, the load moves through a vertical distance, L, equal to the lead of the screw. The screw was one of the last of the simple machines to be invented. Records indicate that the water screw, or screw pump, was first used in ancient Egypt, some time before the Greek philosopher Archimedes described the Archimedes screw water pump around 234 BC. It was used as a wine and olive oil press in the time of the Roman Empire. It is used in modern machinery for a variety of purposes, including continuous transmission of motion, as it is seen in a screw conveyor, just a mechanism that uses a rotating helical screw blade, usually within a tube, to move liquid or materials. They are used in many bulk handling industries. Screw conveyors in modern industry are often to move semi-solid materials, including food waste, wood chips, aggregates, cereal grains, animal feed, boiler ash, meat and bone meal, municipal solid waste, and many, many, many others. In addition to the Mighty Five, there is a sixth simple machine, a wedge, a triangular-shaped tool. It can be used to separate two objects or portions of an object, lift an object, or hold an object in place. Anyway, knowing the velocity ratio of the machine, the mechanical advantage could be obtained as the relation of the efficiency and the velocity ratio for any of the simple machines described. Let's apply these concepts to solve engineering problems. Dr. Lorenz Garcia here, Thanks for watching. Ciao.